Hello guys, this time we're going to learn how to calculate the energy changes in reactions. So get ready with your calculator and your chemistry notebook. Bond energy. This is the list of bond energy. Okay, each bonding has their specific bond energy and they are calculated in the kilojoule per mole. Okay, so example here, hydrogen to hydrogen bonding, the bond energy is 436. Nitrogen to triple bond nitrogen is 946. Okay, so basically this list of bond energy awak tak perlu hafal sebab dalam exam dia akan bagi. So you hanya perlu tahu macam mana nak guna sahaja. Okay, alright. Example here, 240 kilojoule must be supplied to break the bonds in a mole of chlorine molecule. So inilah chlorine and chlorine molecule. To break the chlorine-chlorine bonding here, we need 242 kilojoule per mole to give a chlorine atoms. If these atoms join again to form molecules, 242 kilojoule of energy are given out. So if you want to break the bond, kita akan absorb 242 kilojoule energy. But kalau the chlorine tu dia nak combine balik menjadi chlorine molecule, they need to given out 242 kilojoule energy. Macam itulah guna dia kan. Right, how to calculate the energy changes? Okay, this is the formula used. Energy in minus energy out. Ataupun kat sini energy in is endothermic lah, energy out is exothermic. So energy in ni bila untuk kita break the bond. Okay, energy out ni bila kita nak form bonding. Okay. Alright. This is an example of a reaction between the decomposition of the ammonia into nitrogen gas and hydrogen gas. So untuk kira bond energy, okay, we must expand the structure, the chemical structure of the compound. Okay, kat sini kita boleh tengok. Okay, ini nitrogen, ammonia. Okay, one nitrogen is bonded to 3 atoms of hydrogen. Okay, nitrogen gas N2, okay, dia bonded in a triple covalent bonding. Okay, and then hydrogen gas is bonded into single bond. Okay, 2 kat sini kena follow lah, ikut kan 2 and then 3 kat sini. Right, so based on the bond energy, kat sini dah bagi dah dia punya nilai, kita hanya kira saja. So energy in or energy absorb mestilah kita fokus kepada bond breaking for the reactant. Okay, kat sini kita ada berapa type of bonding? Kita ada satu type saja, which is N nitrogen to hydrogen. Okay, nitrogen to hydrogen bonding. Okay, ada berapa? Ada 1, 2, 3. So kita tengok sini apa jadi Right, so 3 sebenarnya kan, but bila ada 2 kat sini kita kena 3 darab dengan 2, so all together is 6. Okay, so that's why 6 times N to nitrogen to hydrogen bonding. So 6 times 391 is equal to 2346 kilojoule. Okay, now we are going to calculate the energy release or energy out. For, okay, we have nitrogen triple bonding covalent. Okay, yang ni lebih nilai. Okay, 1 darab 1 sajalah. Okay, so 1 darab 946 dengan 946 kilojoule. How about hydrogen? We have 3 hydrogen to hydrogen bonding. So 3 times 436 is equal to 1308. Jadi kena tambah tak dua-dua? Yes, kena tambahkan total untuk energy release is equal to 946 plus 1308 is equal to 2254 kilojoule. So to calculate energy changes, energy in minus energy out. So energy in 2346 minus 2254. So it's equal to 92 kilojoule. Based on the energy absorbed and energy release that you calculate here, we can see that the energy absorbed is greater than the energy release. So total energy changes for this kind of reaction is an endothermic reaction sebab nilai energy absorb tu lebih besar daripada nilai energy out. So positif, okay, positif kat depan ni indicates it is an endothermic reaction. Okay. So this is the energy level diagram kat sini. Alright. Energy in is greater than energy out here kat sini. Alright. So that's why it is an endothermic reaction. Overall, this is actually overall. Okay, next, the reaction between hydrogen gas and nitrogen gas. Sorry, this is actually chlorine gas. Okay, hydrogen gas react with chlorine gas to produce hydrogen chloride. Okay, kat sini ada typo sikit. So first we expand the bonding. Okay, H to H, Cl to Cl, and 2HCl. Now we also have the list of chemical bond energy. Okay, tak ada masalah kat sini. So we're going to calculate the energy changes. We must calculate the energy in and energy out first. So energy in here is we have one hydrogen to hydrogen bonding, so 1 times 436. Okay, and then chlorine to chlorine pun ada satu juga. So 1 times 242. So total energy absorbed in this reaction is 436 plus 242 is equal to 678 kilojoule. Okay, energy release between bonding hydrogen and chlorine. Okay, 431, tapi dia ada 2, you kena darab dengan 2 lah. So 2 times 431 is equal to 862 kilojoule. Change of energy is equal to energy in minus energy out. So 678 minus 832 is equal to negative 184 kilojoule. So based on this calculation kan, energy in dengan energy out ni, kita nampak the amount of the energy released is greater than the amount of energy in. So we can conclude that the total energy changes for this reaction is a negative. So this reaction is an exothermic reaction. Okay. So negative signage here indicates it is an exothermic reaction. Okay, so kalau tengok kat sini, this is energy in, bonds breaking. Ni energy out kat sini lebih besar dia punya nilai. Okay, that's why the overall energy changes there is equal to negative 184 kilojoule. So let's take a look at the past year's question. Kita terus tengok sajalah Okay. Bond energy is the amount of energy in kilojoule which must be supplied to break the bond, what mole of the bond. Okay, so dalam soalan dia bagi dah kat awak jenis bonding dia dengan dia punya energy, bond energy. Okay, use the data in the table to show that the following reaction is exothermic. So dia dah bagi tahu dah reaction ini adalah exothermic. Dia suruh awak buktikan sahaja. So untuk buktikan kita mesti kira energy changes. Okay, to calculate the energy changes, we must calculate the energy in and energy out first. So energy in yang ni Okay, first kita ada bonding carbon double bond, carbon covalent bonding. So ada satu saja, 1 times carbon double bond carbon. So nilainya adalah 610. So 1 times 610 is equal to 610. Next, kita ada carbon single bond carbon bonding. So nilainya adalah 346. So darab 1 jugalah. 1 darab carbon single bond carbon 346. Dan kita ada hydrogen to carbon bonding. Okay, kita ada 1, 2, 3, 4, 5, 6. So nilai carbon to hydrogen adalah 415. So 6 times 415. So kita dapat 2490 energy in. Okay, ada satu lagi bonding energy in dekat sini adalah hydrogen gas. So hydrogen to hydrogen is 463. So 1 times 463 is equal to 436. So total energy in adalah campurkan semuanya. So you will get 3882 kilojoule. Okay. Alright, energy out. Let's take a look at the energy out. So kita ada carbon to carbon bonding. Okay, nilai dia 346. Okay, ada berapa banyak carbon to carbon bonding? Single bond, kita ada 2. So 1, 2. So 2 times 346. Okay, 2 times 346 is equal to 692. Okay, and then we have carbon to hydrogen bonding. Okay, carbon to hydrogen bonding ada berapa? 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 415. Okay, 8 times 415 is equal to 3320. Jadi total energy out is equal to 4012. Okay, based on the energy out, energy in ni pun, kita dah boleh nampak the energy out, the amount of the energy out is greater than the amount of energy in. So kita dah menjawab dah soalan ni sebenarnya. Okay, so inilah jawapan dia. So energy out is greater than energy in. Okay, bila kita kira energy changes, okay, energy in minus energy out, 3882 minus 4012 is equal to negative 130 kilojoule. So second reason, negative sign indicates the reaction is exothermic. Second example of question. Bond breaking is an endothermic process. Bond energy is the amount of energy needed to break or form 1 mole of the bond. Complete the table and explain the forward reaction is exothermic. Okay, ni reactant Okay, nitrogen react with hydrogen to produce ammonia. Okay, so untuk reactant ni adalah endothermic reaction because we are going to break this bond. Okay, alright. So nilai bond untuk nitrogen, triple bond nitrogen is 944. Energy change is 944. Exothermic or endothermic? Endothermic lah because we are going to break the reactant. Hydrogen pun sama. Dia adalah endothermic. Sebab dia reactant, kita nak break the bond. So endothermic for hydrogen to hydrogen. Okay. Energy change for nitrogen hydrogen. So ini adalah bond forming yang baru. Produk yang dihasilkan adalah bond making lah kan between nitrogen dengan hydrogen. Jadi kita ada 3 nitrogen to hydrogen bonding times 2, so altogether 6 lah. So 6 times 388 is equal to 2328. Okay, so biasanya untuk produk dia adalah exothermic reaction sebab dekat produk kita akan form bonding yang baru. Forming a bonding will release heat energy. So this is exothermic. Alright. And then explain the forward reaction why is exothermic. Kita nak explain the overall reaction kat sini adalah exothermic. Of course kita kena kira dia punya energy changes. So kita kena kira energy in dengan energy out lah. So total energy is total energy in is equal to, ni tambahkanlah, kita dah kira tadi kan, 944 plus 1308. Total energy in, yang ni lah. Okay, hydrogen dengan nitrogen gas, tambah dapat 2249 kilojoule. And then total energy out is 2328 kilojoule. Okay, based on this energy in and energy out, we can see that the total energy out is greater than energy in. So kita dah menjawab soalan, cuma kita nak conclude saja di sini. Energy out is greater than energy in. And the energy changes, kita kira lah energy in minus energy out. So 2249 tolak 2328 is equal to negative 79 kilojoule. So the negative signage here is indicates the exothermic reaction. Okay, iklan sikit. The way to get started is to quit talking and begin doing. Alright, this is application for energy from fuels. Okay, a fuel is any substance we use to provide energy. We convert the chemical energy in the fuel into another form of energy. We burn most fuels to obtain their energy in the form of heat. So biasanya energy ni dalam bentuk heat lah ke, mostly Alright, fossil fuel. Okay, fossil fuel ni dia contoh-contoh ada coal, petroleum, natural gas contohnya methane. It is the main fuel used around the world. So we burn them to release heat energy. The world use up enormous quantities of fossil fuel. For example, nearly 12 million tons of petroleum every day. So what makes a good fuel? Okay. The burning of fuel is an exothermic reaction. So the more heat given out, the better, as long as the fuel is safe to use. How much heat does it give out? We want as much heat as possible per ton of fuel. Does it cause pollution? If it causes a lot of pollution, we may be better off without it. Is it easily available? We need a steady and reliable supply. Is it easy and safe to store and transport? Most fuels catch fire quite easily, so safety is always an issue. How much does it cost? The cheaper, the better. Okay, two fuels growing in importance is ethanol and hydrogen. So ethanol is a kind of alcohol with the formula of C2H5OH. Okay, kalau nak tahu dia ethanol tu, kita ada nampak OH dekat sini. Okay, tahulah dia adalah alcohol. Okay, it can be made from many plant material. For example, it is made from sugarcane in Brazil and corn in the USA. It is used in car engine on its own or mixed with petrol. Okay. Second one is hydrogen. This gas burns explosively in oxygen, giving out a lot of energy. So it used to fuel space rocket. It is also used in fuel cell to give energy in the form of electricity. Okay, fuel yang selain daripada fossil fuel tadi, kita gunakan ethanol dengan hydro. Different amount of heat as you compare, the bigger or the larger the amount of the heat given out, the better the fuel. Okay, example here, natural gas giving out 55 kilojoule heat energy. Ethanol given out 86 kilojoule energy, and hydrogen given out 143. Negative kat sini, negative signage here means it is exothermic reaction, exo release heat energy. Okay, the greater the amount of the heat energy release, the better the fuel. So between 3 kat sini antara yang terbaik. Okay, fuel yang terbaik adalah hydrogen. Okay, kita ada satu lagi, nuclear fuel. Okay, nuclear fuel are not burnt. They contain unstable atom called a radioisotope. Over time, these break down naturally into new atoms, giving out radiation and a lot of energy. But it can also force radioisotope to break down by shooting neutrons at them. That is what happened in a nuclear power station. The energy given out is used to heat water, to make jets of steam, to drive the turbine for generating electricity, and etc. The radioisotope uranium-265 is commonly used in nuclear fuels. When it decays, the new atoms that form are also unstable and break down further. Okay, nuclear fuel ni adalah sejenis bahan bakar juga, tapi beza dia dengan yang lain-lain, dia tak menggunakan combustion method lah. Okay, they are not burn. Okay, ini saja dia are not burn. They don't need oxygen to react. So dia hanya perlukan satu energi untuk heat dia punya atom, and then dia pecah kepada atom-atom yang lain. Inilah energi yang dihasilkan. Okay. But it is not all good news, as we know that nuclear is a hazard, is dia bahaya kan, nuclear ni. Okay, apa yang tak bagusnya about nuclear is, first, an explosion in a nuclear power station could spread radioactive material over a huge area carried in the wind. The waste material produced in nuclear power station is also radioactive and may remain very dangerous for hundreds of years. Okay, sebab radioaktif ni dia akan efek pada manusia, dia boleh menyebabkan kanser. Okay, finding a place to store its safety is a major problem lah. Okay, walaupun dia produce energi yang sangat banyak boleh digunakan, tapi dalam masa yang sama dia release juga radioaktif, which is so dangerous to human being especially lah. Okay, alright, that's all. Thank you.